Okay, pre-calculus kids, here come the notes and examples from section 6.1 on solving rational equations. Now, a rational equation is an equation that has a variable has a fraction, and so it's got some kind of a polynomial in the numerator and some kind of polynomial in the denominator. And so there's all sorts of different kinds. Let me show you a couple different situations, and the way that you approach them is a little different based on how they appear. So if I'm looking at this first one, see how this is a single fraction, one numerator, one denominator, one numerator, one denominator. So when you have something like this, the easiest way to solve this kind is to cross multiply. I'll show you how to do that in just a second. Same thing's going to go with example 2, because this 3 is a whole number and it has an invisible denominator of 1. So again, you have a single numerator denominator, a single numerator denominator, and so you can cross multiply. That's the easiest way to solve that type. But when you get down to example 3, that no longer applies, because now you have a single fraction plus a second fraction equaling a third fraction. Now you've got three different fractions involved in this. You can no longer just cross multiply. All right, so we're going to start out with examples 1 and 2, where you can cross multiply to solve, and then I'll tell you about how you're going to approach a problem like example 3 when there's 3 fractions involved. Okay, so up here, cross multiply means take the numerator and multiply it by the denominator. So 4x plus 7 times 1 is 4x plus 7. And then cross multiply the other way, kind of like an x, right? So you take 7 and multiply it by x minus 4. Well, you no longer have fractions, which is happy dance time. So you're going to just distribute through and solve for x. So here we go. 4x plus 7 equals 7x minus 28. Distribute the 7. And then solve for x. So I'm going to bring my 4x over here. I'll have 3 x's. Bring my 28 to the other side. I have 35. Oops, if I can say it, I just can't write it. 35. And then I divide both sides by 3. That gives me an x that is 35 thirds. And yeah, you can leave it that way. It's an improper fraction, but that's fine. All right, so the last piece of this whole thing is you have to check for what's called extraneous solutions. They're ones that cause a denominator to equal 0. So anything that makes a denominator equal 0 is considered extraneous. So in other words, if I go back here and I plug in my answer, 35 thirds, it's kind of like 11 2/3. If I put that in here, is that going to be a 0? And the answer is no. The only thing that's going to make this fraction have a 0 denominator is a 4. My answer is not 4. So I know that this is a perfectly valid answer. Here we go. 35 thirds. You'll see when we talk about extraneous how they work. But all you're doing is taking your answer, plugging it in, and making sure it does not come out to be a 0 denominator, and this one won't. So that's your answer. Number 2 can be done the same way because, again, it's a single fraction equaling a single fraction. And so I can cross multiply. 3 times n minus 5. 3 times n is 3n. 3 times negative 5 is negative 15. 1 times this craziness is that craziness. And so looking at this one, I need to solve for, in this case it's n. And I'm going to have 2 answers for n because I've got a square. This one's a quadratic, which means that everything's going to have to be on the same side of the equal sign, and I'm going to hope and pray that it factors at that point. So let's check it out. If I bring everybody to the right, I'll have a 4n squared. Negative 3n when I bring it over here. 12 minus 3 is 9. Plus 9n. And then take 15, it's negative, bring it over here, it's going to be positive, so I have plus 5. Now, like I said, I hope that's going to factor. Let's see what it does. It has to be an AC method, so 4 times 5 is 20. Factors of 20 that add up to be 9 would be 4 and 5. Divide by the leading coefficient, which is a 4. 5/4 is fine. Reduce 4/4, and you get 1 over 1. So here I go. I have one grouping, these are n's, one grouping that's n plus 1, and one grouping that's 4n plus 5. And then solve them both. So n plus 1 equals 0, gives me n equals 1. 4n plus 5 equals 0. Swing the 5 to the other side, it becomes negative divided by 4. That's an n, not an m. N equals a negative 5/4. All right, let's check them. If I go back to my denominator, this one's just 1, so I don't have a variable. This guy, if I put a 1 in here, 1 minus 5 is negative 4. That's fine. That works. If I put a negative 5/4 in here, that's negative 1 and 1/4. That's not going to give me a 0 denominator either. So both of these answers are valid answers. They're both good. So single fraction, cross multiply, and solve it out. Now example 3 is different, right? Example 3 now has 3 different fractions involved. And in order to add or subtract fractions, you need a common denominator. So I have 3 fractions. I have 1, 2, 3. I need a common denominator between all 3 of them. So I need to have each denominator represented. So I need an x in my denominator, my common denominator. I need an x minus 3 group in my denominator. And I need an x minus 3 in my denominator, but I already have that, so I don't have to repeat it. So the common denominator between these 3 things is an x and an x minus 3. And then it's a matter of comparing them. So if I compare this guy, he has an x. I'm just looking at the bottoms. This guy has an x and an x minus 3. So this one needs to be multiplied by x minus 3 over x minus 3. I'm going to do this one the long way, and then I'll show you some shortcuts. All right, so let's do that. 1 times x minus 3 is x minus 3. That's my new numerator. X times x minus 3 is my denominator. That's awesome. This guy needs to be, he has the x minus 3, he needs the x. So he's going to be multiplied by x over x. 1 times x is x, that's my numerator. X minus 3 times x is my denominator. And the last guy has the x minus 3 piece, he needs to be multiplied by x over x. Well, x times x is x squared. X times negative 2 is negative 2x. X times x minus 3 is my denominator, and I'm good. All right, so it's a matter of getting the common denominator and then making the fractions match that. So you're going to multiply the numerator by whatever it takes to make that happen. All right, here's the best part. And again, I'm going to show you the long way this time and then show you shortcuts the next round. Once you have the common denominator with everybody, it is a legal math move to multiply each piece by x times x minus 3 over 1. X times x minus 3 all over 1. X times x minus 3 all over 1. And you say, well, why would you do that? And the answer is, and again, it's a legal math move because I did the same operation to each piece. So remember, keep an algebra balance. Whatever you do to one thing, you got to do to everybody. Well, you just did it to everybody. And here's the reason why you do that, is because this x times x minus 3 cancels with that one. And this x times x minus 3 cancels with that one. And this x times x minus 3 cancels with that one. And what you're left with at this point is just the numerators. So you're left with x minus 3 plus x equals x squared minus 2x. And you have just gotten rid of all of those fractions, all that ugliness. And all you need to do is solve this for x. So let's bring everybody to the same side. I will have an x squared on the right. I have, this is the same thing as 2x minus 3, so bring this 2x to the other side. It's positive now. It's going to become negative. Minus 2x is minus 4x. Take this negative 3, bring it to the other side, you get a positive 3. And then the hope is that you're going to have this thing equaling 0. And so let's see. If I look at x minus, I need factors of 3 that add to be negative 4, so x minus 3, x minus 1. Right, they multiply to positive 3 and add to negative 4. So x equals 3 and x equals 1. Now let's test them. You have to always check for those extraneous solutions. If I put a 3 in here, go back to the original, I get 1/3. That's fine. But if I put a 3 in here, look what happens. 3 minus 3 is 0. It doesn't work. So this guy is our first example of something that's extraneous. When you solve for x, it works out to be a solution. But when you plug it back in, it's not going to give you an answer. You're going to get 0 denominators which don't exist. So he's extraneous. He gets ignored. How about 1? 1 in here is 1. 1 in here is negative 2. Negative 2, they're all fine, they don't create the 0. So this is your only answer for that particular question. You've got that x equals 3 that turns out to be extraneous. It doesn't work when you plug it in. All right, example 4. Again, I have 3 fractions. I can't do the easy way that I did numbers 1 and 2. So number 4, if I take common denominators, I have 3 fractions. Here's my 3 fractions. Between a 4, and a 2, it's a 4. You're thinking of the times tables and the smallest number they would all have in common. But I also need an n, just an n. Remember, 1 of everything has to be represented. So I have the 4, I have the n, I have the 4. I can change a 2 into a 4, and I have an n. So everybody is ready to roll for common denominators. So then you make the comparison. 4n, 4n, well, they're the same, so keep the numerator the way it is. 4 has to become a 4n. This guy needs to be multiplied by n. Technically, it's n over n, but really it's just looking at the numerators. So that gives you 1 times n is n. Here's my new numerator. And then the last guy is a 2n that I'm trying to turn into a 4n, so he gets multiplied by 2. So take that 2. 2 times n is 2n. 2 times 2 is 4. All right, here's where the trick comes in, right? You multiply by 1, and you can only do this after you get the common denominators and figure out what your new numerators are. Then you multiply everybody by 4n over 1. Cancel, cancel, cancel. And you're left with just the numerators. So I have n minus 3 equals n plus 2n plus 4. So let's see what we got. We have n minus 3 on the left, and on the right we have 3n plus 4. Solve for n, take an n away. Take the 4, subtract it over, negative 7. Weird answer, but n equals negative 7 over 2. Check it out. If n is negative 7 over 2, will this be 0? The answer is no. That doesn't even have a variable. This one, if n is negative 7 over 2, will that be 0? And the answer is no. So the answer for this guy is negative 7/2. There are no extraneous solutions to that one. Example 4. Okay, example 5. Flip it over. You've got a couple choices for example 5. Here's your story with example 5. If you notice on the left, these both are identical denominators. One option would be, because they're already common denominators, is to put them together as a single fraction. So you could put it together as 1 minus x minus 4. You got to distribute that negative over this denominator equals 1 over 3x plus 6. Now if I were to do that, then it's like examples 1 and 2 where I've got a single fraction so I can just cross multiply. A second option would be to factor this and get common denominators all the way across like we just did the last two examples. So I'm going to take this, since they have it set up so nicely, I'm going to combine these first two because they've got a common denominator. 3x squared minus 3x minus 18. Right hand side is 1 over 3x plus 6. But let's check out our numerator. It's going to be 1 minus x, and a negative distributed to the positive 4 makes this minus 4. So if I combine like terms there, I have a negative x minus 3. Negative x minus 3 all over 3x squared minus 3x minus 18 equals 1 over 3x plus 6. And again, because I have single fraction equaling single fraction, I'm allowed to cross multiply, and that's what I'm going to do. So negative, and this is going to require me to FOIL, so I'm going to kind of come off to the right here so I have some space. If I FOIL negative x times 3x, that's a negative 3x squared. Outers, FOIL, FO. Negative x times 6 is a negative 6x. I, inners, negative 3 times positive 3x is a negative 9x. And last, negative 3 times positive 6 is a negative 18. Equals. Remember, this allows me to get rid of fractions. Equals 1 times this crazy thing over here, 3x squared minus 3x, can I squeeze it in, minus 18. Just barely. All right, so let's bring everybody together and see what happens. So if I look at this, I'm going to go left because it's just how we normally put the x's together. This is a positive 3x squared. It's going to come over here and join up with the negative 3x squared. Remember, when it crosses the equal sign, it becomes negative, so really you have a negative 6x squared. This gives you negative 15x, 6 and 9. So when I bring this 3x over, he turns positive. Negative 15 plus 3 is negative 12 x's. And the 18, oh, check him out. The 18 comes over, he becomes positive, joins up with the other 18 that's negative, and they become a whole lot of nothing. So it equals 0. Now let's factor this. This one is, what do they have in common, right? You don't have to do the whole AC method type thing to this guy. I have a negative 6x that they have in common, which will leave me with, now I'm dividing, negative 6x squared divided by negative 6x leaves me an x. Negative 12x divided by negative 6x is a positive 2. So I set those pieces equal to 0. Negative 6x equals 0. X plus 2 equals 0. X equals 0. X equals negative 2. So I get two answers, but now I got to check, is anybody extraneous? So if I put a 0 into here, it'll be 0, 0, 18. That's fine. 0, 0, 18. 0, 6, that's 6. So this is a good answer, x equals 0. If I put a negative 2 in, though, well, let me do it into this one. This is the easiest one to see it in. 3 times negative 2 is a negative 6, and negative 6 plus 6 is 0. So it does not work for this one. It doesn't even matter. You don't even have to check these guys. If it doesn't work for this guy, it's automatically extraneous for the whole thing. So this guy is an extraneous answer. It is not part of your solutions. All right, example 6. This one I have 3 fractions again. I don't have anybody in common that I can just add them together or subtract them like I did in example 5. So I have 3 fractions I need to come up with a common denominator between those 3. So I'm looking at the numbers first. 3 times tables, 2 times tables, 6 times tables. What's the smallest number that they've got in common? And that would be a 6. Everybody got to have a 6. I have no p, I have a p, and I have a p squared. So you've got to take the biggest exponent out of these guys. So this is a p squared. And that's it. That's your common denominator. So now it's a matter of matching. If I want to change a 3 into a 6p squared, I need to multiply by 2p squared. 2p squared times 3 gives you 6p squared. If I have a 2p and I want to change it into a 6p squared, I need to multiply it by 3p. 2 times 3 is 6, p times p is p squared. And then the last one doesn't need anything because it already is a 6p squared. So let's see. 2p squared times 5, that makes this a 10p squared. 3p times 1 makes this a 3p. This one doesn't need anything, he stays a 1. Once you have the common denominator all the way across, you can cancel them out. You're multiplying by 6p squared over 1, and it cancels them. So what you have is 10p squared plus 3p, I'm going to bring the 1 over, minus 1 equals 0, because the only way I can solve that, since it's a squared function, is to factor it. So I need to put my factoring thoughts together. This one is an AC method, 10 times negative 1 is a negative 10. Factors of negative 10 that add up to be 3. Well, that would be a 5, because it's positive 3, and a negative 2. Right, 5 times negative 2 is negative 10. 5 plus negative 2 gives you 3. Divide by the leading coefficient, which is 10. Negative 1 over 5 on one side, a 1 over 2 on the other side. Put your groups together. These are p's. 2p plus 1, that's this guy. 5p minus 1. Take those guys and set them equal to 0. So you'll end up with the 1 coming over on the other side, becoming negative 1 divided by 2 is a negative 1/2. Second one, the 1 comes to the other side, becomes positive, divided by 5, 1/5. Will you have a 0 denominator? The only thing that's going to make this a 0 denominator is if p were 0. That's not what you have. So you plug them in, you're not going to have zeros. So these guys are good. They're both good answers. Ain't nobody extraneous in that guy. So there's example 6. Example 7 brings up a new topic, and that is that, again, you've got 3 fractions, so you have to have common denominators amongst all of them, right? So you're going to have the 3. This one's an x minus 6, so you'll know you need an x minus 6. You know you need an x minus 2. But what about this guy? I'm not sure what the heck he is. So I've got to go off to the side and I've got to factor this. I need numbers that multiply to 12, but add to negative 8. That's going to be x minus 6 and x minus 2. And most times it's going to be at least one of these groupings from your original stuff. So kind of check that out first as you're factoring. It should be that when this denominator factors, it factors into at least one of these 2 groupings, if not both, which is what this one did. All right, common denominator again, I need an x minus 6 and an x minus 2. I need an x minus 6 and an x minus 2. Then it's a matter of matching. This guy has the x minus 6, he needs the x minus 2. This guy has the x minus 2, he needs the x minus 6. And this guy has it all, so he doesn't need anything. So let's figure out the new numerators. 1 times x minus 2 is x minus 2. X times x minus 6, now it's a positive x, so positive x times x is x squared. Positive x times negative 6 is minus 6x. And the 4 we said doesn't need anything. So after you've gotten the common denominators all the way across, they cancel out. The math move is that you're multiplying each piece by x minus 1 times x minus 2 over 1. And that cancels them all out. So I'm left with just my numerators. X minus 2 plus x squared minus 6x equals 4. Again, I'm going to have 2 answers for x because it's a squared function. So let's combine like terms first and then see what we think about factoring. I will have an x squared. I will have a minus 5x. I will have, let's see, I have a minus 2. when this guy comes over, he becomes a minus 6. And so then I'm factoring this thing, or hoping that it factors, and it does. Two numbers that multiply to negative 6 but add to negative 5. Now some of you, don't write this yet, some of you might think, oh, negative 2, negative 3. Which does give you the negative 5, but the problem is when I multiply them, I get a positive 6, not a negative 6. So they do not work. Got to try again. In order to get a 5, I can also do a negative 6 and a positive 1, right? They would also give me that negative 5. They multiply to give me the negative 6, and they add to give me the negative 5, so that's the root that I want. Actually, this one doesn't have to do the divided by because it's only a 1 in front. So it's going to be x minus 6 and x plus 1. So I'm going to take those and solve them, take them the next step. X minus 6 equals 0 gives me x equals 6. X plus 1 equals 0 gives me x equals negative 1. Let's check them out. If I put a 6 in here, red flags, right? 6 minus 6 is 0. This one's extraneous. This one doesn't work. Negative 1, that'll be negative 7. Negative 3. 1 plus 8, that's definitely not going to be 0. So your answer is just this guy. Example 7, we're close to done. Example 8, we actually have 3 to go. Example 8's the last example, and then I have 2 practice problems that I wanted to do. And then we'll be done. All right, so example 8, looking at this guy, let's factor. If I factor this denominator, now one of my hints is maybe it might be an m plus 2. Let's think about that. If it's an m plus 2, two numbers that multiply to 6, add to 5, then this one would have to be an m plus 3. Check it out. 2 times 3 is 6. 3m, 2m is 5m, and there you go. So let that other grouping be a help to you to factor it. This 5 is over 1. It's a whole number. Again, I've got 3 fractions. I can't combine any of them to make things better, to try that cross-multiplying trick, so I'm just going to go with the 3 fractions. Here it is. I need a common denominator for each one, so I need a grouping of m plus 2. Everybody's got to be represented. I need a grouping of m plus 3. And I need a 1. Well, the 1's fine. So this is an m plus 2. I already have it. That's my common denominator. I need an m plus 2. And I need an m plus 3. Okay. Do your comparisons. This first guy already has exactly what it is, so it doesn't need anything. This guy stays at 2. Let's go to the third fraction because the second one's a bit messy. Third fraction has the m plus 2. It needs an m plus 3. So I'm going to multiply this guy by m plus 3. That gives me my new numerator at the end is 2 times m, 2m. 2 times 3 is 6. So there's my last guy. But let's now go back to this middle one that's a bit ugly. This one needs an m plus 2 and an m plus 3. It needs both. Well, isn't that the same thing as this? M plus 2, m plus 3. And the reason why I'm looking at that is because it's going to make it way easier for me to multiply this 5 through. If I look at it this way, I'm going to have to FOIL it first, which gives me this, and then distribute the 5 through. So I'm going to have 5 times m squared is 5m squared. 5 times 5m is 25m, and 5 times 6 is 30. All right, you're through the worst part. Now you've got all your denominators can cancel out. And you're left with just the numerators. So let's see what we got. 2 plus 5m squared plus 25m plus 30 equals 2m plus 6. That's the best part after all those denominators cancel each other out. Again, I'm going to have two answers for m because it's a squared function. So let me pull everybody together and think factoring. I will have a 5m squared. If this 2 comes over and joins up with my 25, this is positive, becomes negative, take 2 away, I'm at 23. This is really 32. If I take 6 away from 32, that's this 6, comes over, 32. 32 minus 6 is 26, right? Yes. All right, so plus 26. Holy moly, this gets into some crazy AC stuff, right? So I'm thinking about this. If I take 5 times, by the way, nothing factors out, not like you've got a common factor between 5, 23, and 26. So the best I got is this. So 5 times 26, I'm going to come over here to the right. 5 times 26 is 130. I need factors of 130 that add up to be 23. Now, for the sake of time, I will tell you, it's 10 and 13. If you think about that, 10 times 13 is 130. 10 plus 13 is 23. So that works. So take it and divide it by your leading coefficient. Simplify if you can, and put your groups together. So one of the groups is going to be m plus 2. Second grouping is going to be 5m plus 13. Take those groups and set them equal to 0. M plus 2 equals 0 gives you m equals negative 2. 5m plus 13 equals 0. 13 rolls over, becomes negative, divided by 5, so negative 13/5. Check them in your question. If I have a negative 2 in here, well, look right here. Look at this guy. Negative 2 plus 2 is 0. Automatically, you can see that that's not going to work. So I get this guy's extraneous. If I put negative 13/5, that's like negative 2 3/5. Definitely not 0. Definitely not 0. So this is your answer. All right, last little bit, number 6 from the practice problems. They were all the examples, so we're done all the examples now. If I go to number 6 from the practice problems, again, I can't do the cross multiplying thing because I can't combine them into a single fraction and a single fraction. So I've got 3 fractions that I need to get common denominators on. I need to have an x plus 4 represented. This one's just a 1, whole number. And I need to have an x minus 1 represented from over here. That's my common denominator, x plus 4, x minus 1. Everybody's got to have the same denominator. And so now I'm doing a comparison deal here. If I have x plus 4 and I don't have an x minus 1, that's what this guy needs to be multiplied by, x minus 1. This guy needs, actually, he needs both. He needs an x minus 1 and an x plus 4. I'm kind of running out of room up there. This guy has the x minus 1, it needs the x plus 4. Shoo, watch and see this one. This one's going to be a really ugly, big old numerator going on. First one's not so bad. 6x times x is 6x squared. 6x times 1 is minus 6x. The middle guy, remember, needed both. And I don't have the trick like I did back in example 8 where they had it multiplied out for me. So I really need to multiply this out. I'm going to FOIL this out. X times x is x squared. Plus 4x minus 1x is plus 3x. And negative 1 times 4 is negative 4. So I just FOILed that out so that now I can distribute this 4, positive 4 at that, through this whole thing. So 4x squared, 4 times 3 is 12x, 4 times 4 is 16. Shoo! But wait, there's more. The last one I need to multiply this, so this is going to require me to FOIL. So 2x times x is 2x squared, my firsts. Outers, 2x times 4 is 8x. Inners, 2 times x is 2x. And last, 2 times 4 is 8. That was a lot of work, which is why I picked this one. All right, all of your denominators can go. Gone, gone, gone. And you're left with just whatever the numerators are. So let's see what we got. I have 6x squared minus 6x plus 4x squared plus 12x minus 16 equals 2x squared plus 10x. I can put them together, right? Plus 8. Let's do another round of cleaning up. On the left, I have 10x squared, negative 6, positive 12, so plus 6x, minus 16, 2x squared plus 10x plus 8. All right, let's put these together now. 2x comes over here, subtracts from the 10, becomes 8x squared. 10x is positive, comes over here, joins up, becomes negative. 6 minus 10 is minus 4x. 8 is positive, comes over here, becomes negative, so I've got minus 24. And if I look at this, everybody's divisible by a 4. So if I divide everybody by 4, him by 4, him by 4, him by 4, that's going to help me to be able to factor this better. The other thing you could do is factor out a 4. Same idea. If you factor out a 4, you're going to have the 4 on the outside of the parentheses. When you set 4 equal to 0, it can't happen, so it just gets ignored. So, but either way, so I'm dividing by 4, so here I go, 2x squared minus x minus 6. And I'm going to hope that that factors. So 2 times negative 6 is negative 12. Factors of negative 12 that add up to be negative 1 would be negative 4 and 3. Divide by the leading coefficient of 2. Put it together. X minus 2, that's this guy, 2x plus 3. So for this one, I get x equals 2. I get x equals, bring the 3 over, it'll be negative, divided by 2, negative 3 over 2. Plug them back in. Gosh, where was the original problem, right? Up here. 2 is going to be 6, that's fine. 2 is going to be 1, that's fine. This is negative 1.5, that's not going to be 0. That's not going to be 0, and so both of these are valid answers. All right, here comes the last one. Last one, woohoo! This is also a practice problem number 9. I can't combine these together so that I can use that cross-multiplying method, so I just got to go with the 3 fractions. Here it is. 1, 2, and 3. Well, I need an a plus 1 from this guy. I need an a minus 1 from this guy. This guy, now think about factoring him. He's the difference of 2 perfect squares. You can take the square root of a squared. You can take the square root of 1. Square root of a squared is a. Square root of 1 is 1. In order for you not to have a middle term, one of them has to be positive and one of them has to be negative so that they cancel each other out. Oh, check it out. A plus 1, a minus 1. That's what this factors into. All right, so back to our common denominators. I need an a plus 1. I need an a minus 1 for everybody. Do your comparisons. So this guy has the a plus 1, he needs an a minus 1. This guy has the a minus 1, he needs an a plus 1. This guy has both, it doesn't need anything. So here we go. 1 times a minus 1 is a minus 1. 1 times a plus 1 is a plus 1. And then this is a 2. So this one was way easier than the last guy. Once you have your common denominators, you can cancel out those denominators. Bye-bye, Mr. Denominators. I have just the numerators. A minus 1 plus A plus 1 equals 2. This one isn't going to require factoring because see how I don't have a square on anybody. So I'm just going to take and combine like terms. A plus another A gives me 2A. Negative 1, positive 1 cancel each other out. Equals 2. Divide by 2. And I get A is 1. So you go back and plug it in. Well, 1 in here is great. That gives me 1 plus 1 is 2. But 1 in here is a problem. 1 minus 1 is 0. And so I would end up with a 0 denominator for this guy and also for this guy too. So this guy is extraneous. And that is really kind of weird because if it's extraneous, then do I have any solutions to this problem? Is there a solution? There's an answer, but it doesn't work when I put it back in. So that means that for this entire problem, the answer is no solution. The answer I got doesn't work in the problem. So if that happens, you have no answer. So there's no solution to this particular problem. All right, there's your section 6.1. Shoot me an email if you've got any questions on anything, and I will see you soon. Bye.